This is lesson 5.2, special cases of linear equations. We start with a recap of our three forms of linear equations that we learned last lesson in 5.1. We have the slope-intercept form, standard form, and point-slope form. In this lesson, we're going to start with some special lines that have unique linear equations, and these are our horizontal and vertical lines. As we learned in chapter 4, a horizontal line has a slope of 0. So if you were to plug this into our y equals mx plus b formula, the m is just 0, so the entire mx term goes away, leaving us with just b. So the equation of a horizontal line is actually just y equals b. In other words, y equals the y-intercept. So in this graph here, the green line is a horizontal line. It has a slope of 0. The equation of that line is just y equals 3. There's nothing else that you need in this equation, because what this is actually saying is y equals 0x plus 3. And of course, we don't have to write this because anything times 0 is 0. A little bit trickier to understand is the vertical line. Remember, vertical lines have an undefined slope. So this actually doesn't work with any of our three forms. You can't substitute in m as being undefined. So the only way we can represent vertical lines is as the equation x equals whatever the x-intercept is. So in this red line here, this example, it's a vertical line that's going through x equals 1. So that's just the formula of the line, x equals 1, or x equals whatever the x-intercept is. So if you want an easy way to remember this is horizontal lines, they're just y equals the y-intercept, and vertical lines, those are just x equals the x-intercept. There's no other variable with these equations, there's no other numbers with these equations. So first example, we want to write the equation of a horizontal line that passes through the point 1, negative 3. So I've just sketched it out. You don't actually need to graph it, but what would this look like? Well, if that was approximately the point 1, negative 3, and the line was horizontal like this, we can see that the y-intercept is at negative 3. It doesn't really matter. The 1 here doesn't really matter. What does matter is the y-intercept of negative 3. So then that means the equation is y equals negative 3. And that's all there is to it. We know the slope is 0, so there's no x involved here. There's no m. It's just y equals the y-intercept. You could also go right to your answer if you know it's a horizontal line and it's going through a point, just take this y value there. Other type of question here, write the equation of a vertical line that passes through the point 2, 1. So again, I sketched it out very briefly to get a visual idea of what it would look like. We can see here that the x-intercept is 2. So the equation is just x equals 2. Again, you could have done this quickly. If you notice it's a vertical line, you just look at the x-coordinate of the point given to you. Next, we'll do a reminder of our parallel and perpendicular lines. We know what they look like. We know what some examples of them in the real world are. Now we want to look at the equations of parallel and perpendicular lines. So first, let's note, what would identical lines look like? Of course, their equations would just be identical. So for example, 2x plus 3. If they're the exact same line, then they have the exact same slope and the exact same y-intercepts. Everything about them is the same. For parallel lines, though, we know that parallel lines have equal slopes, but what's key is that the y-intercepts have to be different. This is what differentiates between identical lines and parallel lines, is that the y-intercepts are not the same. Because if the y-intercepts and the slope are the same, you just have the exact same line. And identical lines are not parallel because they actually intersect at every single point, because they overlap at every point. So in order for them to be parallel, they have to have the same slope, but different y-intercepts. So you can identify parallel lines quite easily if you're given equations of the lines in slope-intercept form, because you can check, like in this example, they have the same slope of 3 and different y-intercepts. So that means that these are parallel lines. For perpendicular lines, we know that the slopes have to be negative reciprocals of each other. But what about the y-intercepts? It's actually pretty flexible. The y-intercepts could be the same or they could not be the same. It doesn't matter. If they are the same, then that is their one intersection point. If the y-intercepts are different, that's okay. They would intersect somewhere else. So for this first example, looking at the equations, we know that these represent perpendicular lines because the slopes are negative reciprocals of each other. You don't even actually have to look at the y-intercept because it doesn't matter if they're the same or different. In this case, they're different. And then in the second example, again, we know they're perpendicular lines because the slopes are negative reciprocals of each other, and it just so happens that the y-intercepts are also the same. So in this example, we want to determine if these two lines are parallel, perpendicular, or neither. You don't want to graph, we just want to look at slopes. So what you're going to do first is convert them to slope-intercept form and then compare the two slopes that you have. We're given them in standard form. So you should have practiced this by now. We're going to isolate for y by bringing the x over, and then we'll divide by 2. So we would get 3 minus 1/2 x. So y equals minus 1/2 x plus 3. That's the first equation. And for the second equation, we would bring the 2x over and then just rearrange it, 2x plus 3. So when we compare these slopes, we see that the slopes are negative reciprocals of each other. We flip them and change the fraction, or sorry, change the sign. And then it happens that the y-intercepts are the same, but it doesn't actually matter when we're working with perpendicular lines. So you put a final sentence explaining your understanding. The lines are perpendicular because their slopes are negative reciprocals of each other. Same type of question again, we've got two different lines and we want to see are they parallel, perpendicular, or neither. We're given them in standard form. Let's convert them to slope-intercept form so we can easily compare the slopes. So we want to isolate for y. We bring the 3x over, we'll divide by -1, -5 plus 3x, and then we'll rearrange 3x minus 5. So this is the same line, we're just writing it in a more useful form. Same for the second line here, let's isolate for y. We'll divide by 2, that gives us 6 plus 3x, and put everything in the right order. Okay, so what do we see? And these have to be parallel lines because the slopes are equal. The slopes are equal and the y-intercepts are different. So you have to list both of those pieces of information when explaining this. The slopes are the same, the y-intercepts are different. Because remember, if the y-intercepts were the same as well, these would be identical lines, not parallel lines. The last thing to go over in this lesson is how do you write the equation of a line if you're given 2 points? You're not given the slope or anything in particular, you just have 2 points. This is where our point slope form comes in handy. You're given 2 points, you're going to first calculate the slope using our formula that we've done a bunch of times before. And then you can pick either of the points given to you and substitute that and the slope into the point slope equation. You can always convert to another form later if you'd like. So for this example, write the equation of the line passing through these 2 points. We just use our slope formula that we've done a bunch of times before and calculate our slope of -3/8. And then I'll just pick the first point. So I'll plug in my y value of -2, my slope goes here, my x value goes here. My final answer, I just get rid of these double negatives, so I've got y plus 2. So that's one way to represent this line. Or you could have done it in green over here. If you had picked the second point, that's okay too. You sub in your x and your y values, and that's the equation you would get. So although these look different, it represents the same line. And then this last example is the same idea. The only thing slightly different about this is that one of the coordinates is 0. So you would find your slope like normal. But if you happen to choose the point that includes 0 as one of the coordinates, your final answer might look a little funny like this. Because once you plug in the coordinate of 0, you don't have to write x minus 0. That just simplifies to x. So at first glance, this might not look like point slope form because there's not a bracket here with an x value, but it is. It's just that that x value is 0. And then again, in green, I've written the other equation you might have got from this if you had picked the second point instead. Either of those is fine. So we know now the equations of horizontal and vertical lines, the equation of parallel lines or perpendicular lines. We know how to write equations of lines if we're just given 2 points.